Go ahead and pause the recording if you haven't checked out this problem yet. But they want us to use sheet 4 of this data set. And they want to test the proportion. Now this can be tough because we're used to calculating for means, but they want us to test something around a proportion. So we need to have a p hat. We need to know a number of successes in this data set. The package must contain 3 ounces or more of chocolate stars. So this one does not contain 3 ounces or more. It's 2.87 ounces. So this is a failure. So we put 0 next to it. This is a success. That's above 3 ounces, well, which is what they're looking for. This is above. So a quick way of doing that is you can type equals if, start a conditional in Excel or Google Sheets, equals if A4, cell A4 is greater than 3, put a comma, and then put 1. That tells Excel to put the value of 1 in this cell if it is bigger than 3, if it's a success. But then put a comma and put a 0 in to tell Excel to put a 0 in if it's not greater than 3. And then you can just click and drag. That way you don't have to scan each number. Okay? So that calculates whether it's a success or a failure. So you can type equals sum and then do B1 colon B50 to add up all those numbers. Equals sum B1 to B50 for my Excel sheet. So there, that's a quick way of finding out that we had 36 successes. So 36 out of 50 met their conditions for success. So it's 0.72 for our sample proportion. Here's the formula I'm going to be using to calculate. Well, actually, let's type that in first. That's, oh, what are you doing? 0.72 goes here. Z is going to be 0.72, and then the previous is thought to be 0.8. Then divide by the square root of this value is your p down here, 0.8 times 1 minus 0.8. The value assumed to be true under the null hypothesis. And then the sample size, we had 50 numbers in our data set. Okay, so like I've shown in a few other videos, my trick is to do the parentheses first in the denominator, and then that gets multiplied to 0.8, and then divide by 50, and then take a square root. And so I'm going to copy that. That's my bottom of my fraction. Now I can go up to the top, 0.72 subtracted by 0.8, divide that by the denominator. So I got z is negative 1.414234. Yeah, that's probably enough. Just copy a bunch of these values. That's probably good right there. They usually want just like 2 decimal places. But man, I hate this notation. P means the population proportion. ZyBooks shouldn't be doing this. ZyBooks should just write out p-value. I'm going to write them a letter. But this means p-value, not population proportion. The p-value is something that we have to use the hypothesis statement to help us calculate it. And so if let's read through. What are they trying to test here? In order for a candy company to claim that a bridge mix is mostly chocolate stars, the proportion needs to be at least 0.8. Quality control tests a random sample. Evidence exists that the proportion of packages with 3 ounces or more of chocolate stars is okay. So this is the key down here. They want us to test to see whether the proportion is less than 0.8. So our alternative is p is less than 0.8, and that means our null hypothesis is that p equals 0.8. So we're trying to test to see whether it's less. That means we need to know that for the p-value when we type in a z-score calculator. Okay, if you type in z-score to percentile calculator, take the first one, type in our z-score wherever they want us to, negative 1.414234. And that's why it's important. Our the percentage is 7.86%. But when you're talking about a p-value, it's the decimal form of that percentage. So 0.0786 is our p-value. 0.0786 is the p-value. And now that p-value is greater than 0.05. So the null hypothesis we fail to reject. We can't reject the null hypothesis. You get to go with your alternative, with your hunch, if your p-value is low. Since our p-value is greater than 0.05, we fail to reject the null hypothesis. There's not enough evidence. Okay, so I'm going to leave the rest because there's a few other videos I got to make for these. I think they're all the same type of thing. You got to read through. It's usually at the end when you try to identify the null and alternative hypothesis, and that dictates which direction you're looking for a p-value. So this one says more. They're talking about a proportion that's more than 0.15. So that's your alternative. So you want a right-tailed p-value in that calculator that we looked at. I guess another thing I can do is I can help with the table here. Sheet 1 of the Excel file. So if I go to Sheet 1 on the bottom, they're looking to see whether it's greater than $50,000, right? So this first one is less than $50,000. I'd want to code that to be a 0. Man, a lot of these are going to be. This is less than $50,000. So what you want to type is equals if, open parentheses, if, oh wow, I'm also starting in the wrong spot of the sheet. I didn't see that. Okay, so type, get out of here, there we go, equals if A1 is greater than $50,000, no comma there, put a comma after that, A1 is greater than $50,000, then we want to code a yes, code a 1. Put a comma and put a 0. That tells Excel to punch in a 0 if it's not greater than $50,000. And then you can just drag that. That way you don't have to count each and every one and check to see whether it's greater than $50,000. You can just do what we did in the last problem, equals sum B1 to B75. So there's 13 out of 75. So my sample proportion there is 0.17333. So that's what you'd use for p-hat.